Hello, Giuseppe and Mauro. I hope you can hear me. Well, if you can, we are on the top of the hour, and as usual, we'll wait 3 or 4 minutes before starting to let more people joining. And I know Karsten may be a bit late today. Can anyone confirm that my audio works?
Yeah, works well for me. I can hear you.
Hi, Christian. Okay, so being 4 past, I think we can start, and again, Karsten should be able to join a bit later today. But welcome everyone to the interim meeting of the co-working group. I am Marco Tiloka, my co-chairs are Jaime Jimenez and Karsten Bormann. And as usual, this is an official IETF meeting, so the not well applies. Please be familiar with that if you're not already. It's not about IPR, it's also and especially about our conduct. So be nice and professional with one another. And the agenda for today is only about 2 points. I'll quickly go through the status of some working group documents and their progress, but then we will mainly focus on a tutorial about the IPPM mechanics and building blocks in the interest of the co-op PM document. I think Giuseppe will mainly present, but I see other co-authors also in the roster. Does anyone want to bash this agenda? Heard none. I'll try to take minutes, by the way, but any help would be appreciated. So on the document status, I just wanted to mention three here. Thank you. I just wanted to mention three of them. On Young Seed, there have been a couple of design team meetings recently. It's pretty clear to the others what they have to do. But they plan to have one more round of feedback in order to produce a revision before the cutoff, so that we can consider a working group last call right after that. And then we would be able to process the outcome of that at IETF 116. So that's on track. And yesterday, we also started intentionally in parallel the working group last call for two other documents, the profiling of EDOC for co-op and OSCORE, involving also the Lake Working Group is very much related, and the core target attribute registry document, which is very short. So of course, please have a look at the documents. Even saying they're fine as is good feedback. Please provide your comment on the list or on the GitHub, especially if it's about needs and editorial suggestion. And the call will end on February 28th for both of them. Okay, that said, I think we can leave the floor to Giuseppe, I believe, as main speaker. But of course, you can switch slide control.
Okay. I will present the general idea of the draft and some aspect of the methodologies. Then I also invited other co-authors from Telecom Italia, Mauro and Fabio, that will describe you also much more details about the implementation and also the the hackathon activities around these methodologies. So Telecom Italia has also a field implementation of this methodology. So they further discuss the implementation details. So can I present, or because
definitely. Actually, the slides are available on Miteco, and you can take control of them. If you go on the top left of your screen, the first icon the second one. Yeah, you pick the right one.
The second one. Yeah.
I'm just granting you permission right now.
Yeah. Okay, good.
There you go.
Okay. This draft aims to, define a performance measurement option for co-op. This is the 03 version that was published last year. So what are the motivations? So we want to extend the mechanism to measure the performance for co-op, because you know that co-op protocol need a simple mechanism for network diagnostic, since it needs to be developed on constrained nodes, and we need just a minimal amount of collaboration between the endpoints. Since it is resource consuming to read sequence number or ID or store timestamping, in IPPM and also in QUIC and TCP, there is a new effort to study new performance measurement technique called explicit flow measurement, that aims to employ few marking bits inside the header of each packet for loss and delay measurement. And all these methodologies are described in the draft explicit flow measurement in IPPM, and it has been submitted to ASG for publication. Let's say the background for this kind of techniques are the reason that, for example, for QUIC, you have that the header is encrypted. So a non-path observer that can be an operator or let's say a segment network that want to measure, for example, the performance of QUIC, of TCP, or TCP, cannot implement the measurement. So let's say there was this new effort to employ few marking bits in, let's say, in an encrypted header of QUIC or TCP, in order to allow on-path observer that can be network operators or network probes to make the measurement of these encrypted protocols. So this is the motivation for, let's say, the original drafts. So we had the idea to extend this kind of measurement also to co-op protocol, since we believe that this kind of measurement are really easy to apply also in the context of co-op.
Sorry to interrupt you, Giuseppe. I just quickly saw Christian in the queue. If you had a question on the run.
Do you want to take questions now, or shall I pull them for the end?
As you prefer, and for me it's the same. Yeah, if you maybe go ahead. Yeah, you can.
Brief question here. You mentioned in QUIC, basically the endpoints are cooperating even though the rest of the traffic is encrypted. Is this something that is widely is this something that clients widely collaborate on? So say if I'm using Firefox to download a gigabyte of data, will it use a QUIC connection and play along with EFM?
Yeah, this is a good question, because in this draft there are several methodologies that are described. This is an informational draft. In QUIC, only one bit of these of the several bits that are described in this draft is optional and is the spin bit. But let's say so there is the spin bit that is dedicated. Regarding the real implementation, I know that Telecom Italia make an implementation through a client on the smartphone. Maybe later on Fabio and Mauro will describe much more details, but I don't think that from what I know, I don't know if Firefox or Apple really implemented this optional bit, but it is optional in the QUIC, let's say, standard documents. I don't have this information about the real implementation of in Firefox or Safari or Microsoft Edge and so on. So, but of course, you need that the client and server implements this kind of measurement to realize that. This is just to give you the picture of why we started to study this measurement and why we are now proposing that for co-op. Maybe I can go ahead. This is the first kind of explicit from measurement. So it is the spin bit. So basically, as I said before, it is implemented optional in QUIC protocol. Okay, there is the reference, but also if you look at the QUIC, the RFC 9000, or also the QUIC manageability RFC, I don't remember the number, maybe 9312, the spin bit is defined as optional. The idea is really simple. So is to create, let's say, a square wave signal between client and server using only a bit, and the length of the signal is the round trip time. So in this way, an observer on path can measure the end-to-end round trip time only watching the spin bit. So the good way is that the observer does not need to take any timestamp or ID. So it just needs to measure the length of the square wave, because the length of the square wave is equal to round trip time. So
brief question here. This does assume that both peers are sending at capacity, right? So if you're doing this in co-op and one node is just sending intermittently, this stops giving you anything, or does this still contain any useful information?
Yes, it is supposed that there is traffic. Of course, if there is no traffic, but if you have a connection between the between your client and server. For example, if we consider quick, so we suppose that the measurement is done if there is traffic. So if there is the message and the acknowledge in the other direction. So in this way, you can measure the round trip time. And if there is no traffic, or if, as you said, the traffic is not regular, your measurement is affected. Or and if you have regular traffic, your measurement is really accurate, while otherwise, if it's not regular, it can be affected. But of course, if there is traffic, I think that the measurement can be done, because if you send a packet, it is supposed, for example, for TCP quick, that you will receive an ACK, so at least you will make one cycle, and at least one sample, you are able to measure one sample at least. Of course, if you have a continuous traffic, you are able to measure much more samples, and you can have much more statistical data about the round trip time. Yeah. This is about the spin bit. The other is the square bit. So this allowed the measurement of a one-way packet loss. So also in this case, there is an RFC that is the alternate marking. This is a standard track document defined in RFC 9341. The applicability to quick is also described in this individual draft from Orange and Akamai, that they also implemented these methods in a real network. So in this case, for packet loss, you always have the client-server connection. You have the two-direction upload and download. In this case, you have to measure the two direction separately, because if you create a square waves of a well-known length, for example, 64 packets is just an example, you may see that an observer on path is able to recognize if there is a packet loss by simply counting the number of packets for each square. So if, for example, you measure the number of packets of less than 64, you can recognize a packet loss for a particular square waves. This is the square bit signal. So the idea in our draft, maybe you may recall the past presentation, is to define a new option where we can use 1 or 2 bits depending on which kind of measurement we want to do, if packet loss or delay. And we also added other event bits that can be used, for example, to signal some loss event or delay event bits for probes that, for example, do not support this kind of measurement. So we can make use of the additional bit, but of course this can be further discussed. So let's say the main idea is to use these options to implement the spin bit or square bit. Now we can go through the co-op applicability. So what are the real usage scenarios for this kind of measurement? Basically, the co-op performance measurement options allow this end-to-end measurement, but split measurement are also possible, because if you have on path observers, and as you may notice in the previous slides, so both spin bit and square bit allow on path measurement from an observers. So you may have network function, probes, or gateway or COAP proxies that can perform also measurement. So we can have, and we can distinguish between different cases. So the case of non-proxying endpoints, the case of collaborating or non-collaborating proxies, depending on the proxies that support or not the measurement, and the case of host core. So the first two cases are really simple. So in case of non-proxies endpoints, let's say you have a very simple scenario. So in general, you have client and server with the observer in the middle. And in this case, you can make end-to-end measurement. But since you have the observer in the middle, that can be a network probe or can be a network gateway and so on, that of course need to be able to read this kind of measurement. Can also do on path upstream and downstream measurement. And also if you have more than one observer, if you have, for example, two observers, you can also, let's say, measure the segment between two observers. The case of SCORE, let's say, does not create additional issue, but of course the co-op performance measurement option needs to be sent as an outer option. In this way, it can be visible also on path. Let's say the more complicated scenario, maybe Marco, go ahead.
Yes. Sorry to interrupt, Giuseppe. Can you go back to the previous slide?
Yeah.
Yeah, when you mentioned about outer option, sure. But do you mean actually to have it an inner and an outer option at the same time to cover both end-to-end and on-path measurement, perhaps?
This needs to be discussed. Of course, Massimo, my colleague Massimo Mauro Fabio also plan to work on an implementation. So for this, we want to discuss with you because for SCORE, we just read the let's say the standard document. We see the opportunity to have an outer option to make visible this kind of information also on path, but how to implement that, we need your advice, of course.
Yeah, like for other options that can be both outer and inner, it's not that the two things have to be mutually exclusive. So you can actually make the measurement happen in both end-to-end and on path, I believe. But
okay.
An early thought. Thanks.
Okay, good. Thank you. Regarding the other scenarios with the proxies, let's say that things are a little bit more complicated because, of course, we define this option that can be applied end-to-end between client and server or between the collaborating proxies. And we define this option as safe to forward. So it means that it is intended to be forwarded by a non-collaborating proxy. In this way, also in the case of non-collaborating proxy, we should be able to make some measurement. So in case of collaborating proxies, of course, you have three sessions, right? So between client and the first proxy, between the two proxies, and between so this is let's say the most complicated use case where you have the three separate sessions. And in this case, you can, since the sessions are separated, you can measure the three connection also separately. So you can do in the end-to-end measurement, but also on path upstream and downstream, bottom the observer, because of course the observer can also read the performance the performance information between client and proxy, or if you have an observer between the two proxy, also the observer can read the performance information between the two proxies and so on. And also you can do intra-domain measurement if you have more than one observer on a single connection. For example, if you have between the two proxies, if you have more than one observer, you can also make the measurement between the two observers. For example, we suppose that here between the two proxies you have internet, so it is supposed that a network operator can also make, for example, a segmented measurement. In case of non-collaborating proxies, if we suppose that the option is safe to forward, you have, in theory, you have a single connection, and you can do always end-to-end, but also if you have the observer, of course, you cannot make the measurement on the proxy because the proxy is not collaborating, so it just forward information. But you can still do the measurement if you have on PubTop observers. So you can make upstream, downstream, and also intra-domain if you have more than one observer. So in this case, you lose the measurement on the proxies, yeah, in theory. Of course, here, please.
I think this is the topic that we will need to discuss most. Like the other scenarios are, to me, pretty clear. This is the one where we should probably go through one example, and then either you see that it doesn't work or I see that it does work. But this is the one I would like to focus on.
Yeah, I fully agree with you because this is the most complicated case, because since you have that proxy is safe to forward, there are a lot of complications here, because we have to decide whether the proxy, when forward let's say the option, if it can be forwarded for all the packets comes from all the clients here, or if we suppose that it is just one client. So this need to be further analyzed. We also plan to make an implementation. Indeed, in this regard, we also have a question for you about any suggestion on the open source implementation, because since we already implemented all this kind of measurement on Quick, we can easily do also on Co-op. So we would like maybe to analyze much more, because since this use case is a bit more complicated, I think that with the real implementation we can have much more knowledge about how to really implement it. But I agree with you, this is the most complicated case that need to be analyzed. The other one are pretty much clear. Yeah. Since Marco asked also to describe the additional methods that are reported in the explicit flow measurement draft, I just want to give you an highlights of the other methodologies. So for now, we only propose the spin bit and the square bit because are, let's say, the most straightforward, are the most easy, also are really easy to implement, as you noticed. But just for your knowledge, I want to describe the other methods that are under discussion. This is an additional bit that is called the delay bit. Is not like the spin bit, but it allows, like the spin bit, allows round trip time measurement. And the marking bit is called delay bit, and the packet with the delay bit equal to 1 is called the delay bit sample. So you only select one sample each round trip time. So you have a single market packet generated by the client and bounce between client and server using the production traffic. So let's say it is really similar to the idea of the spin bit, but you only have one packet, so you don't have a square wave. So in few words, of course, when the client does not detect a sample, you need to wait a specific time, otherwise you have to declare the packet lost and you have to regenerate the delay bit sample. So let's say, in short, there is an algorithm also in this case that is really very well described in draft, but just to give you the idea. This is the delay bits option. So how to measure the delay by using 1 or 2 bits. And you see that the draft analyzed that the best option is to have 2 bits for the delay, because you uncouple both the spin bit and the delay bit, and the number of measurement will be very high, and also the resiliency to impairment is really high, because with spin bit the resiliency to impairment is really low, because if you have a square wave, and of course if you have issue on the, and if you have some packet loss, this will also affect the spin bit measurement. So this is just some proposals to improve the accuracy of the delay measurement. For packet loss, there is a similar approach. For example, there are defined additional bits. One is the so-called T-bit round trip packet loss. The idea is really simple. So the Q-bit is a square wave of that is continually generated between client and server, and is one way. In this way, the T-bit is round trip, so the client generates a train of market packets. The server need to cooperate in this case, because need to reflect these packets. For example, if the market packets are in red, the server, when the server reflect, of course, we suppose that the download flow has more packets than the upload. So in this case, you have blue packets that are not marked, and the red packets that are marked. So the server, let's say, reflect always the same number of packets that receive, but will select only some packets according to the packet rate that there is. So it is always the lower packet rate that decide the number of packets that will be generated. In this way, you can measure the packet loss. This is an additional bit that is defined together with the square bit. Another bit is called the loss event bit, is called the L bit. This is, let's say, more useful when you have QUIC or TCP, because the L bit allows to mark a packet each time the protocol detects a lost packet event. And this loss bit can be also coupled with the square bit. Another bit is the reflection square bit. Before I mentioned that the square bit is only allow only one-way measurement, but if you want to reflect the square bit in the opposite direction, you can define this reflection square bit that, let's say, where the sides of the transmitted air bit blocks are, let's say, the average size of the received qubit blocks. And in this way, you can have a continuous alternate marked blocks in both directions. So this is just to, let's say, overcome the limitation of the qubit that is only one way. And also in this case, there is this summary that is also described in our draft, and report the different options. So you can use the T-bit alone, you can use the square bit alone, on the loss event bit alone, or you can also couple the square bit and loss event bit, or the square bit and the reflection square bit. The idea is to, let's say, improve the measurement accuracy, to couple more methods, and also to make more measurement, because in one case, for example, with the square bit alone, you can only do upstream, but with the other, by coupling, for example, the qubit with the R bit, you can also do much more measurement according to the number of observers that you can put on path. An additional proposal is to, because if we can implement this probe directly on a user device or on a server, the device owner or the server owner decides whether to mark the traffic and decide whether to share this performance information. So there are some strengths to implement the probe on board on the client or on the server. Is the same, because there are scalability. You can have more scalability because on the user device there are few connections to monitor. You can do also more precise measurement. You can measure both direction, and also you can save some equipment because it is possible to set alarm thresholds on user device and to signal to the network probe to have a sort of coordination between the host and the probes. But this is an additional idea just to describe you what is progressing in IPPM. Yeah, I pretty much finished my presentation. Yeah, this is just to discuss the next steps. Now I want to give the floor to, I don't know, Massimo, Fabio, if they want to add much more details about the Telecom Italia implementation to the hackathon implementation, because there are also implementation from Ericsson, from Akamai that are collaborating with us, mainly in Quick. But of course, with Fabio and Massimo, we discussed how to implement this also in co-op. So I don't know, Fabio, Massimo, can you introduce? Yeah.
Go ahead, Massimo and Fabio. Yeah, you need to switch on your mic explicitly with the mic button on the top left. For now, you are just in the queue.
Can you hear me?
Yes.
Yeah.
Hi.
Yeah.
Okay, perfect. Yes, I will present with my colleagues Fabio and also Mauro, if you want, our implementation in Telecom Italia team, and something about the architecture, and also about a little recap of what are the other implementations that are actually was made. I have some slides.
So do you plan to share your screen?
Yes.
Please go ahead. It's yet another icon, the third one from the left in that row.
Okay.
That's right.
Okay.
Yes, as Christian also says, by the way, it's good if you can also submit your slides to the data tracker. If you haven't already, because Miteco at least doesn't show me any new deck to import.
You don't see my screen?
I do. Just after the meeting, no rush, if you can also submit the slides
Yes.
or upload them to the data
I
tracker.
submit the slides just before the meeting. Sorry, just a few minutes. I already submit on the IETF.
Now I see your mail. They don't seem available in Miteco for being imported. That's interesting.
Ah, okay.
But thanks. Then we should be fine. Thank you.
Okay. Okay. I will send you on your email.
Thanks.
Okay. Okay. I try to go full screen. Okay. It's okay.
It's full screen now.
Okay. Perfect. Yes, this is about the architecture of our, let me say, our like a proof of concept of our implementation of performance monitoring. In particular, it's about the use case in our mobile network. Here is an overview about the implementations that are already made. Like, for example, in the hackathon IETF, we have a project normally that is called the Quick Measurements. And then there are also some explicit flow monitoring implementations and some contributors. So obviously, our implementation in on Android mobile devices probe. There is an implementation inside Ericsson network with network probes. Another is related to Orange, a collaboration between Akamai and Orange. That is, it involves the cache servers, cache network, and some probes inside the core network. So also Huawei is working on this, is on this topic in explicit flow measurements. And we have also had some collaboration with the Aachen University in Austria. And there is also some white paper that was presented in NNRW about the different methods that we have implemented for packet loss measurements that we proposed, sorry. And a kind of POC also related on implementation on Intel Tofino in P4 language. We have also collaborations with the Politecnico, the Turin Politecnico. And there is also some development of probes from Technion, the Israeli Institute of Technology. Okay. Here you can view an overview of our mobile implementation with mobile devices, in particular on Android smartphones. Here on the left, you can see the mobile device. On board on the user device, there is a client that is involved in the implementation of the alternate marking. So we can give a color to the packets, and we can use it for the performance measurements. This on the left, you can see the client. On the right, there is a normal server, let me say. It could be a generic, for example, web server that only implements the part that is related to the server side, that normally is involved only is involved in the reflection of the packets with the marking. Another actor in this architecture is the observer. Oh, sorry. In this case, the observer is an app that is installed inside the smartphone on board, and it is involved only on make the measurement mainly about the delay and the round trip time, round trip delay, and eventually the loss. Depends on the method that we use. Okay, so the measurement is related to end-to-end measurement that here is indicated from the location from A and location in Z. So it involves all the connection from client to server mainly with this architecture. Okay. Here is a sample of the source code that we have used for implement on the left, mainly on the markature, and on the right about the spin bit and about the square bit. Fabio, if you can add some detail about this source code.
Yes, hello everyone. Can you hear me?
Yes.
Okay. Okay, this is a small overview of how simple it is to implement the spin bit and the square bit. As you can see on the left, there's the protocol session context that is needed to implement the spin bit together with the square bit, and we have in few words a function that is called every time an incoming packets arrives, and it updates the spin bit status. And the other one is the function that is called whenever we have to send out a packet and we have to update the state of the square bit context. And obviously, every time a packet is produced, we have to read these variables in order to set the header of the packet. So it's really simple, as you can see, and it has a very small computational footprint. Please, there's some question.
Yeah. Just for understanding, so one of these session context structs exists for every established quick connection, for every for tuple of IP and of source and destination IP and port. What is the what is the context that goes into finding this thing?
Yes. Okay. In this case, for quick, the context is the single flow, the single connection. So yes, is the for tuple if we haven't a connection ID. If we haven't connection ID, it is related to the session that is related to the specific session ID. In TCP, yes, it would be the for tuple. Yes.
Thanks.
You're welcome. Okay, so the computational is really small, and as you can see, the implementation needs only few lines of code. So it's really easy to implement this kind of marking in the protocols. Obviously, spin bit and square bit are the most simple. The other bits are just a little bit more complicated to implement, but nothing scary. It's really simple for all the bits. Massimo, you can continue.
Okay. Here is only two slides about some screenshot to stay as documentation, to remain as documentation. This is screenshots of the application that is the client with the performance measurement marking on the user device. We can see live directly now in the demo. And I only to underline that are, for example, these are some kind of the methods that we have implemented. So we can have a measurement about the spin bit only, the delay bit only. That is our one of the methods that we have proposed. The hidden bit is a variation of the delay bit. And then we can also have both the measurements about the delay and the loss. In this case, for example, we use 2 or 3 bits in the header, and we can have the delay measurement with spin bit or delay bit or indent bit plus the loss with Q and R. Okay. This is a screenshot instead about what we call team quick. That is the observer that stay on the user device in this case, but could be everywhere on the path of the traffic. And this is a quick overview about what we can measure related to the quick connection. And okay, I think I can show you directly, explain now what we can see, and then after we can see live on the demo. Mainly about every connection that we describe here, for example, a connection of the protocol is quick. In this case, this is the server, the destination. The state of the connection is closed. This is the total numbers of packets transferred. This is a quick overview about the RTT. We have an average RTT. This is the kind of measurement method that we have. In this case is Telecom Italia, delay bit, QR loss. And then the important things is this row and the second row, the last row, sorry. The first row is about all the measurements that we have, let me say traced, and mainly the interesting one are these 3 that is related to the minimum RTT in the running of the connection, the maximum RTT, and the average RTT. This is the number of measurements that we have done during the life of the connection, So in this case, for example, we use the delay bit that have, let me say, a minor number of measurements, but is more accurate when we have a comparison with the spin bit. The last one is the measurement about the loss. And we have two kind of, in this application, obviously, we have we show a parameter related to round trip loss. This is a percentage. So in this connection, we have had a loss about 0.344% of the packets. And here is the parameter related only to the downlink direction. In this case, that is for example, a file transfer with HTTP, and we have a download of the file. And so mainly the loss is related in the direction where we have the most part of the traffic. In the uplink direction, there are a minor number of packets, and so we don't have loss because the two parameters are quite the same. Okay. If you have any questions, comments.
Yeah, we have a bunch of questions queued in the notes, actually. I think Christian have a few things to ask, especially.
Before I get started with the questions, I'd like to cut down a bit of where we should focus, because I think we should really use today to run through an example of whether or not this option can be saved to forward, because everything after having discussed this will be easier. But I would guess that doing this example together would take something in the order of magnitude of 15 to 20 minutes. And I don't want to cut out like the other questions. Marco has a few in there as well. So Marco, maybe I'd leave it to you to make a decision on how to schedule those against each other.
If your questions are not critical, I think we should prioritize the example building, actually. If it works also for the authors. And my questions also were not critical at all. They can wait.
Yeah, I think for me it works.
Sorry, Giuseppe, you're very quiet. Can you get closer to the mic?
No, I was just saying that it works for me to
Great.
proceed with an example.
Yeah. We can use the same notes that we are using for taking the minutes.
So if it's okay with you, I would start describing a setup as I understand it, and then we'll see from there whether that is kind of, we'll go through how this could work there. So just interrupt me when you think that I'm kind of excessive here, and other than that, I'll start setting this up.
Okay.
I don't know who's Massimo, as you're sharing. Would you mind joining in with the interim meeting notes? I'll just, for convenience, share a link in the chat again. I think it works best if we are all converging on one view here.
Okay.
You are still sharing your screen, Massimo. Is that intentional?
No, okay. Okay, only a question. You want to see something about the real-time live demo or not on the smartphone?
I don't think this will be helpful to the questions that we'll have to work out together.
Okay, okay.
So the setup that I would like to work with here is one with just a single proxy. Should be easy and should be kind of complex enough already, with two clients connected to the proxy and two servers behind the proxy. With the proxy being non-collaborative, because if the proxy collaborates and we're using this as a proxy unsafe option, then to me this is like, okay, yeah, let's just do it. You describe the options, we review it, thing done.
Maybe if I can,
Yep.
I would suggest if someone, maybe you, Christian, or Marco, can share the notes, so we can all view the notes on the.
Yep, let me try sharing this.
You beat me on time.
Yeah, so it is easy, because otherwise we have to open the
Sure.
notes separately.
Yeah. This would be that one. So I'll just move this over to a separate screen now. Maybe a bit of screens. Why can I not increase the font size? I can. 30 minutes. Okay. So I think this would be a font size that we can work with. Let me go down to the example again. Okay. So the assumption that I would like to work with here is that we are having a proxy, we are having a distinct set of clients and servers, and so on both ends the proxy has more than one connection. Now what I think what would happen, and I would like to take as an example, please pick a better one if you think there's a better one, the square bit. Square bit. So the client sends packets, and for the moment I would only think of the client sending packets to the server, because like let's pick the simplest way things can look like. So what the client is sending is 111111110000000, and mixing that.
Yeah.
That is what the client would send. At the same time, because we're assuming regular traffic, C2 is sending something similar, same number or same wavelength of the form, and the packets are interleaved at the proxy kind of randomly. So on the and let's assume further that we are only talking to server 1. So it's for the moment it's even only a single server, and we have our probe down here. So our observer would be here, and let's see whether that observer can do anything useful at all. So the observer sees packets that are all from proxy public IP, from proxies outbound IP, single port, servers IP 5683, because that is the regular port that would be used here, and I should not be flipping around the sizes because this looks weird to you. So what the observer would see would be 11111111. That is like handling the first nibble of packets. Then it might see 11000101, followed by 8. Something like this, followed by 11111111. That is like the pattern that the observer would see. And if we assumed in a just to have a different example and not get caught in patterns, if we had if the phase situation were like this, random but kind of uniform stream of 0 and 1. So my question is this a scenario that you think that the proposal can handle?
Currently, in the current version of the draft, we suppose that to simplify things, that one client is the only one that is sending market packets. So if, of course, there is a proxy, if there are several clients, maybe we assume that only one client send each time. So without any, to avoid this kind of issue. So I remember we already discussed, make similar discussion on the mailing list or during an interim meeting. I don't remember.
Yeah, because
after,
it hasn't concluded. So.
Yeah. And after that discussion, we explained this kind of assumption in the draft. Because of course, in the middle, after the proxy, you cannot recognize the client, so everything is mixed, and yeah, you lose the signal, so you lose the marking information. So of course, so and we have to, and in this case in particular, considering that we are now supposing that we are in the most complicated cases, and we have a non-collaborating proxy, we should suppose that only one client make the measurement. And let's say that this assumption is not so unreal. So because considering that we are in an IoT, so we suppose that all the clients under the same proxy should be, let's say, managed by the same organizations. This is something that can be done. So because the organization can say, the network management can decide, okay, we can monitor one client each time, and then we can make, something like that. So it's something that the assumption is not something impossible considering the real co-op scenario. So
okay,
opinion,
so just from a symmetrical argument, I take it that the same assumption goes for the other side. So what is really the case is that that there is only one link between one client and one server that is ever around one proxy sending marks. Because if you have one,
of course,
like if the probe on the other side, okay.
Because otherwise you have supposed to include some identification, right? If you want to monitor more clients, you need some more identification. But in this case, you let's say that you lose the proxy function because you are also, there are also security and privacy problems in this case. So maybe it's not easy to
you're monitoring traffic. What do you expect?
Yeah, no, I mean, if you want to extend the option to say, okay, in some way you can put some more identification to allow the observer to recognize each client, but it's something that I think is not doable, is not for security and privacy reasons. So
okay, so with that assumption in there, let's go to the next next point where a transparent proxy will break this up. So we are now limiting our scenario to a single client, a single proxy, let me just, and a single server, because everything else is out of scope now. but there are and we still have the observer around like
yeah, let's say that this is the initial assumption. If because let's say we are quite new of this protocol, so if you have better suggestions on how to do that.
My opinion here, right, as things are now, is that you will need to carry this assumption, and if you you can work around it by adding server and client identifying data on both ends, but at this point, why use a proxy anymore at all? Or in other words, you're kind of things get so complex that it's probably easier to ask the proxy to collaborate. But there's more than the multiple clients and multiple servers. So we have this single thing now, and this is only working single client, single server, but the proxy is caching. The proxy may have cached data. So say the proxy has a few, and these will come in streaks. So there will be, especially if we are doing things like downloading firmware, there will be data in the proxy cache, at least for a generic proxy. And again, if this option is to be safe to forward, then it needs to work for a generic proxy. So the observer in this scenario will see everything here. Oh, no, this one. And that it will not see this anymore, and it will start seeing things over here again. And maybe let me, for illustration purposes, shift the phase a bit so that it becomes more visible. Yep. If we do it like this, because otherwise it's like yada keyboards, I would imagine. So suddenly we see something like this, which I think is more than 8 ones in a row. Without an actual packet loss ever having happened. And these are like just the two first functions that come to my mind when it comes to proxying. And again, the question is this something the observer can still use?
Of course, in this case, with this kind of cache, the observer cannot do a good measurement, of course. Yeah, the measurement is affected. Yeah.
So like we could probably go through one or more other options that can happen. But my proposal at this point would be that the option better be non-proxy safe, but to salvage the use cases that you have where it works for particular scenarios where there is, say, only one client ever using this, only one server using this, no caching involved, etc. I would call these proxies that kind of supported, but not really. They would still be free, and that is something that we've seen in other options. They would still be free to treat the option as if it were proxy safe. And given that in this whole scenario, the client and the server already have to cooperate, and there is a very tight set of restrictions applying all around, I think that's not a quite so that's not an excessive demand on a proxy to just have one more option where it knows that, yep, this is something that I can forward without further consideration. That would be my proposal. That will make the whole make all these problems be explicitly limited to the cases that you're describing in the specification.
Can you remind me if we define the option as non-proxy safe, what it does mean in reality? So
It will mean that a proxy that has never heard of this option, and by the way, a proxy that will never have heard of this option might do all of those things that I've been describing here, forward to different servers, cache stuff, etc. That this proxy will just send it on.
Okay.
But if the proxy has just like read the first 3 lines of the specification that say this is critical to this is not safe to forward, but if you tick these 3 boxes, like you're in a controlled environment where you know that you only have one client that does this, and you're not caching, and you're we might extend that list further down as we are reviewing the document. Then you can just ignore all of the rest and treat this option as if it were safe to forward.
Okay. And in that case, the proxy does not apply caching for that.
There is a number of ways this could be implemented. For example, this proxy could, if the proxy has caching in general, it could bypass caching for this option.
Okay.
That would be one way for a proxy, or to just say, yep, it's not, or to say that the proxy isn't caching anyway.
Okay. This is up to the specific implementation of the proxies, I guess.
Yeah, the implementation would need to warrant that if a request with that option comes along, then it behaves like this and that. For other options, it could behave as it wants, but for these options, it will have to behave like doing this, and that, or at least, I mean, the proxy can't do so much about making sure that this all goes only to a particular client and a particular server, because the proxy will not know all those details. But there is some input that comes from the proxy operator, where the proxy operator says, yes, we are using this in such a scenario where you may do this. So we are ticking the one box, and the proxy can tick some of the other boxes, like not applying caching here.
Christian, we have a comment also in the notes now from Karsten. Just checking the details of these definitions.
Yeah, I was just trying to remind people what safe to forward actually means. So safe to forward means that the option contains a bit that indicates to a proxy that does not understand this option that it is nonetheless safe to forward. And as soon as a proxy understands the option, that bit is no longer relevant. So I think Christian is essentially saying, well, it's not safe to forward. So the proxy has to have some understanding of it in order to handle it correctly.
And what I'm trying to emphasize here is that some understanding can be very, very limited.
Yes. So we would define a minimum support that a proxy has to have to make this work.
Even without being fully cooperative.
Yeah, so whatever
Right.
fully cooperative is. So we might have different levels of processing here, and we might have something like a simple proxy that still can forward this because it's not doing some things that would be unsafe.
But overall, I imagine, Christian, you have a clearer idea now.
Can
we say so?
To me, so this is my proposal. If this works for the authors,
no, it looks reasonable for me, because I will look carefully at the, let's say, at the relevant RFC about the proxy safe, no proxy safe rule, because I didn't notice that. And as I said, I'm new of this protocol, so I need your guidance. And of course, I will carefully read that part. But considering your explanation, I'm confident that this is something that can be modified in the next revision. And yeah, I think you it seems that your suggestion is will help this kind of implementation in case of caching proxying. And yeah.
Thanks, that was very good and useful. And there's actually still time for the questions that were queued below. So, Christian, you want to go ahead?
If it's all the same to you, I would do this and move you up there.
Okay, sure. Yeah, I just wondering about the exact word observer. I suspect it just the word officially used when using this mechanism in Quick. Correct me if I'm wrong, because I suspect it can create some confusion that can make one think about a co-op client using observe.
Yeah, we use the observer, let's say, not in Quick, in the IPPM work, because since the IPPM work is, let's say, transport agnostic, so it aims to define methodologies that can be applicable to several client-server transport protocol. So it may be Quick, it may be TCP. So we just define on-path observer. But if, of course, COP folks are more familiar with probe, we can simply replace the wording. It's not a big deal. So
yeah, if probe is equivalent, I think probe would avoid the confusion
it's equivalent
altogether. Okay, great.
Yes.
Yeah, thanks. And yeah, the other question I have came up when thinking of observe. I don't fully understand if this approach becomes less effective or really not providing useful information at all anymore if the specific traffic in question that you try to monitor is using co-op observe. Because it's not that you have real exchanges anymore. It's just a few requests and then a lot of responses at unpredictable times in principle.
Yeah, this is something that maybe, I don't know if, because
but probably you cannot just ignore the observed case altogether. I wonder how you should, what you should do in the observed notifications, basically.
Yeah, it's something that we need to think about this.
Yeah, I don't fully understand this myself, but probably the observed case requires some particular handling.
Yeah, I think the point here is that the option works by having paired packets. So you have a packet going one direction and then a packet going the other direction. And with observe, this is only the case if the notifications are confirmed.
Yeah. Otherwise, of course, you can, because you see that, for example, the square bit allowed to monitor only one direction. Otherwise, you can only monitor one direction in that case. So it's something that, but maybe we can also consider this case as an additional scenario to mention in the draft. Maybe.
Yeah, it's just good to not ignore it altogether, because
it
looks like it has some particular angles.
Yeah, it makes sense, but since the methodology also allow only one way, so in that case you can simply do only the one-way measurement. So you don't need to have traffic on the other direction, and maybe you can simply do only one-way measurement in that case.
Thank you.
But I will add maybe a new section or a subsection to better consider this case.
Thanks, Christian.
I was about to chime in here on the acknowledged observations, but actually this aligns well with the next question. You mentioned scenarios of download flow that has more packets compared to the upstream flow. Quote unquote regular co-op does not do this normally. So there are situations in which you can have multiple a different number of packets in both directions, but the regular flow of requests and responses, if there are no things like observe or no response in play, is that there is lockstepping between those. So in the figures that you've given, are you assuming any particular extensions to co-op that are in use? Because otherwise, there will, without some extensions to co-op, there will not even be a situation where there is more than one request in flight. Or extensions, or like custom configuration, but it's in standard co-op, this is incredibly rare.
So in this case, you are for custom configuration, for example, you mean that let's say the client can send more requests just for measurement purpose or something like that, or what do you mean?
So if a client is running co-op with the default set of options, and it has multiple requests to a single server, then it will send one request, wait for at least an empty ACK to come back, quite possibly even for the response, I don't know that off my head, and will not send another request to that server until at least that round trip has completed. There are tunables in the co-op protocol.
Yeah, that is suitable. Yeah, of course, it's something that it's suitable. Yeah, of course. Because in that case, you will do the measurement for each request at time. So, and then you can wait for the next request. So you don't need to have several simultaneous requests, or it's something that is it can be managed, of course. Yeah.
Okay. And just to pick on a detail that is hidden in there, if there are empty acknowledgements, for example, as when there is an observe notification coming back, those will not be able to carry an option. Are you to carry any option? Are you aware of that?
Yes. This is similar to the answer to the previous question. So maybe in that case, we can only do the measurement one way, because if the acknowledge is not able to carry any option, we can only do the measurement in the upstream, let's say in the upstream direction, only one way.
Provided traffic on that leg is flowing in one direction, which is a assumption that's not too far off given the assumptions that we've had already. Okay.
Yeah, because if it is empty, it's impossible to do. Yeah.
Okay, then there's one more. There are two more things that I've prepared down there. On the qubit, if the implementations, and I think we are at that point now, are collaborating on a single link, we might already have the qubit. Actually, yeah, I think we can skip this because the way we are describing those non-collaborating proxies now, this falls flat. So and the last item, yep. Just one more note of around things that you could utilize. If your measurements are sitting on the end device, which is something that you've indicated is happening, there might already be round trip estimates being taken because there is a flow. So especially when you're using larger data flows, then there might be a flow control protocol sitting inside CoAP that already provides round trip time estimates. So you might want to look into it's not the latest, it's actually Phasor draft, just to see what work there is already on measuring when you're sitting in the client. Of course, this will not be helpful for the probes, but if you're on the end device and if you're measuring the link to your next proxy, this might help.
Yeah, this is really useful information, because considering, for example, that for spin bit you are creating this square signal, and the length of the square wave is round trip time. When you have issue in creating this kind of square wave, you can double check with the round trip time estimation that you already have to see if there is a big difference, and to see if you are if the client is really applied the algorithm in a good way, or if there is some issue. So yeah, it's an information that of course can be used also for comparison, or not only to validate the right spin bit algorithm implementation, but also to validate the measurement on the client side. Of course, the probe, the observer, the probe cannot have this kind of information, but if it is validated on the client side, it is in some way validated also for the probe.
There's a question from Massimo in the chat only about the MTAC. Why not having options? Yeah, it's intended to be very minimalistic and only the 4 bytes header. And especially with the MTAC acknowledging a confirmable separate response, that's about it, confirming reception and carry on. So options are for full-fledged requests and responses.
But let's say it's not a big issue, because if you have an empty ACK, this will not prevent, for example, on the client to produce the spin bit, because for the spin bit you need the acknowledge back to, let's say, to create the square wave. But even if there is no option, you are able to recognize the acknowledge, and you can create the square wave, but only in one direction. Because you can only populate the bits for the option in one direction. But the only limitation that you can only do the measurement if you have an observer on the upstream direction and not in download direction. But normally, let's say an observer a probe that can see the upstream direction is supposed also to be able to see the download direction. So it should not be a big limitation for spin bit or square bit. The only lost information is that you cannot monitor the download direction in that case. But yeah.
Okay, thanks. Just to wrap up, in the interest of time, I suppose you plan a revision to be submitted before the cutoff, and there's already a lot to digest from today, right?
Yeah.
And I planned and still plan to provide a review. I was just waiting to have a better direction on this document altogether and this tutorial now. So I hope I can send out a review version 3 in the next 10 days or so. It's great if you can at least partially take into account for the next revision. And Diana, I suppose you're also available for the IETF 116 meeting.
Yeah. Of course, I plan to review the draft. I think that this is very good discussion. So we got much more information, much more. I have much more clear idea on how to consider all the other cases that we didn't consider in the previous version. So. Do you mean the cutoff for the next IETF? So
yes,
this is
13th of March.
Of course, we are able. There is 1 month, so there is time. Of course,
good.
We will provide a new version. I also hope we can have a slot during the next IETF.
I think it should be doable.
Okay. I'm not sure if I'm able to attend in person or remotely because I'm in the processing of being transferring from Germany to Italy. So I don't know if I am able to come to Japan this time. But of course, I will be available remotely for remote presentation in case I will not be in Yokohama.
Great. Thank you for your up.
Yes,
okay.
Maybe that I will be in presence, maybe.
Looking forward to meeting you.
Yeah.
Okay, we are 1 minute past the time limit. Any quick, very important remark to do as any other business? Okay, heard none. Thanks a lot for a great discussion today. Talk to you in 2 weeks. See you on the list. Thanks. Bye-bye.
You.
Esatto.